Hello and welcome everyone. My name is Emily Dvorak and I will be presenting the role of logistics in a damaged world, mitigation and adaptation approaches to climate change. I will be presenting this research on behalf of Jan Gravenga and Anneke de Bod, who worked with me throughout the year on the study. The logistics sector is a major contributor to greenhouse gas emissions. The transport sector alone contributed an estimated 22% to overall global emissions in 2015. Logistics as a whole encompasses so much more than just transport, and that's why it is so crucial now for the industry to understand what its contributions are. Climate change was only introduced as a serious public concern in the late 1980s, but it has taken the economic sector, and specifically the logistics sector, a lot longer to react to this. The Mickey Mouse model shown in Figure 2 shows the model that most businesses still follow today, with the largest focus on economic benefits and a much smaller focus on the social and environmental spheres. The logistics industry needs to change this model to a more sustainable approach, because not only has the logistics sector been a big contributor to climate change, but the industry will also experience a lot of the adverse effects resulting from climate change. As shown in McKinnon's article titled Adaptive Logistics, published in 2010, there are multiple pressures on the logistics industry to implement change and to adapt appropriately. These include both direct and indirect pressures to implement change. When developing our research framework, our aim was to investigate the current status of academic research on mitigation and adaptation approaches within the logistics industry. The focus areas and questions that we set out to guide this research involved three major points. The first was to identify the key logistics areas that have impacted climate change. The second was to identify mitigation and adaptation approaches that have been researched and proposed in order to address the negative effects of logistics activity. And then ultimately, our aim was to identify the gaps that currently exist in the knowledge about mitigation and adaptation within the industry. It is important to mention that man has been confirmed as the main cause of climate change. 97% of research in this field have identified that human activity contributes the most to high releases of greenhouse gas emissions. This is causing climate change to progress at much faster rates than ever before. From this, leaders in climate change knowledge and research have identified that there are two major strategies we have to consider: mitigation and adaptation. Up until now, these approaches have been kept fairly separate, but there is a symbiotic relationship between the two, and there is also a trade-off between the two. Research into this relationship and the trade-offs between mitigation and adaptation need to be viewed as a combined concept. A big element of these approaches is that logistics plays a major role. The industry needs to take action in order to proactively address climate change and to understand what role logistics activity is playing in contributing to climate change. In order to take action, the logistics industry needs to understand the knowledge gap in this area, and once this is identified, the industry can then begin to implement measures and policies that will contribute to combating climate change. For the purpose of this research, a systematic literature review was conducted in order to analyze the current literature following a pre-planned research strategy. The SLR was chosen because it is useful in assessing literature of specific research topics, minimizing bias in evaluation, and ultimately identifying current knowledge and knowledge gaps within the specific topic. A research protocol was designed to systematically select literature for the review. This research focused on reviewing only academic literature and using grey literature to provide complementary insights into the industry. The research protocol below was developed to ensure that all literature included was current and relevant for the purpose of this research. A research framework was compiled that closely follows the PRISMA checklist for SLRs. This adapted framework and the research protocol guided the research throughout the process. Following the detailed research protocol, the first stage of literature collection took place and provided 168 articles from the academic literature. From these, we screened each article's title to evaluate whether or not the article was relevant to the study. Only 67 of these were identified as relevant to the research, and these 67 articles were selected for the review. Throughout the review process, it was identified that many of these articles were actually not appropriate to be included in the study. 28 articles were excluded because they were not relevant to the logistics focus, and 11 articles were excluded because the only evidence of logistics as a keyword was because these articles performed a logistics regression analysis. Ending the screening process, a final total of 28 articles were coded for the systematic literature review. An initial coding template was developed through the identification of key themes within grey literature, and then the coding template was updated and revised as the coding process continued within the academic literature. Each key concept was first assigned with logistics focus area code, which indicated the specific industry of logistics that the concept was concerned with. The concept was then assigned either a challenge code, in which it would go into more detail as to what type of challenge it was, or a strategy code would be assigned. If a strategy code was assigned, the code would then identify whether it was a mitigation or adaptation strategy, and thereafter it would go into detail as to what type of mitigation or adaptation strategy was identified. This coding template was used for all 28 articles, and a total of 128 codes were assigned throughout the full coding process. The first set of findings from the study is concerned with the time period of publication. Out of the 28 articles that were included and relevant to the study, all of them were published over the last 6 years. As seen in the line graph, there was a slight decrease in the publication of articles from 2014, seeing as 2015 had no article publications. However, there has been a steady increase in open access research since then. The slight decrease in 2019's publications is fairly insignificant, and the 2020 figures also may be slightly less than expected because literature was collected in August. This means that there could be articles published after August that are not included in the study. It's important to note that this research only included open access academic articles. The logistics focus area codes provided very interesting insights into the positions of industries within the research. The warehousing and facility industry received no codes within the academic literature, which points to the fact that warehousing has not received enough research attention. This is cause for concern because there are a lot of things that can be done within the warehousing industry that will help mitigation and adaptation strategies. The majority of codes were assigned to general logistics, which included anything that did not offer insight into a specific industry, but was rather concerned with logistics as a whole. The number of general codes points to a lack of detailed research into specific industries and also process analysis. The fact that it is non-specific means that academic research is not going in depth enough into logistics industries and processes. The maritime industry coding results show that ports are highly vulnerable as an industry. In the literature, one can see that the port sector is facing major climate change risks. But another main contributor to this is global trade. Because as globalization occurs and demand continues to increase, port and maritime activity increases with it. This ultimately is increasing its contribution to carbon emissions. Moving on to the transport sector, transportation showed a surprisingly low representation within the literature. On top of this, the transport that was identified in the articles was not widely concerned with large-scale transportation systems, but was more involved in individual and low-level strategies. This indicates the lack of strategies and research that directly concerns global transportation systems. From the challenge codes, it's evident that a variety of different challenges were identified, but the biggest challenge was the lack of knowledge and the difficulty of understanding within the industry. This involves not only mitigation and adaptation approaches, but also how to implement them, what approaches have been proposed, and a difficulty in assessing their effectiveness. The other noteworthy finding in the challenges was that reducing demand as a challenge did not receive much representation within the literature. This is cause for concern because it highlights how little urgency has been placed on the concept of reducing demand, which involves not only using less, but also not being as fast in terms of immediate demand fulfillment. These results do indicate that the industry has not identified reducing current demand as a problem. Out of 66 codes assigned to strategies, 62 of these were assigned to mitigation. Total value costing was anticipated to be a strategy because it was identified in grey literature. However, it was not found in any of the academic literature reviewed. The mitigation strategies that received the most representation was the investment in new strategies and technologies and policy implementation. These results were somewhat expected because it has been evident that the industry needs to invest in changes in systems that are going to promote mitigation and adaptation in logistics. Also, The identification of policy as a strategy is key because policy will act as a guide and will pave the way for the industry. With policies in place, the logistics industry will have to act in accordance with these, and this will ultimately lead to the implementation and the investment in new strategies and changes that are required. Out of 66 codes assigned to strategies, only 4 were assigned to adaptation strategies. This shows a major gap in research regarding adaptation, but also that there has been a lack of research into the relationship and the trade offs between mitigation and adaptation. Of the academic literature, 3 adaptation strategies were identified, but the key result was that there was a lack of results. There has not been enough research conducted with regards to adaptation, but specifically geoengineering methods and climate proofing. Both of these methods have been identified as strategies in the grey literature, which is why they were expected to be represented here. However, neither of them were mentioned, and this provides key insight into necessary research that needs to be conducted going forward. Our first conclusion is that the majority of research that has been conducted within academic literature has been focused on the logistics industry in general or as a whole. The lack of representation within specific logistics industries points to a lack of detailed process analysis of logistics activity. Future research needs to be conducted at a more in-depth level in order to identify more specific strategies for specific industries. We can also conclude that ports and the maritime industry have been identified as an area of major vulnerability to the adverse effects of climate change. The biggest challenge identified is that there is a huge lack of knowledge and a difficulty in understanding within the industry, not only in terms of how logistics is affecting climate change, but also how climate change is affecting logistics. The other major challenge is that there are conflicting agendas between stakeholders, meaning that collaborative relationships are not being developed to address climate change challenges. Stakeholders still view climate change as a long-term challenge that does not necessarily concern them right now. Reducing demand was not acknowledged as a major challenge. This was surprising because demand reduction was expected to be one of the bigger challenges in the literature. The question that we draw from this is, why does logistics not see demand management as a viable option, or even a challenge in the industry? The world's wasteful way of living is not on the minds of the consumer or the logistics industry. People who have analyzed this see that demand reduction is a potential solution, but the public has not identified demand management as a challenge. Reducing demand is just not acknowledged within the academic literature or the general public. This does ultimately point to a lack of urgency in identifying demand management as a problem. The solutions that had the highest representation within the literature were the necessity for investment, but most importantly, policy implementation. These 2 strategies will work hand in hand going forward because the implementation of policies that specifically address challenges of climate change will ultimately pave the way for the whole industry to then invest in new strategies and systems that are required moving forward. From these conclusions, we recommend that future research is extended to grey literature as well as closed journal articles. The scope of this research did not include these areas of literature, but it is important that going forward, the relationship between academic literature and grey literature is not only established, but is also fully understood. The other recommendation is that future research needs to be conducted at a more detailed level, especially between industries. The interplay between disciplines has not received enough attention in the literature, and this will be crucial for identifying mitigation and adaptation strategies that are going to be effective through not only supply chains, but industry as a whole. Specifically, the relationship between the logistics and the engineering disciplines need to receive more attention in research. Understanding this relationship will help to identify large-scale systems and efforts that will support mitigation and adaptation strategies. I would like to thank the Center for Sustainable Road Freight and the International Scientific Committee for the invitation and the opportunity to share this research with you today. Thank you.